So ordered pairs, as the name suggests, has a specific order about them. The first entry is called the x coordinate of the ordered pair. The second entry of the ordered pair is referred to as the y coordinate. Okay. And these ordered pairs are going to provide an address or a location for a point that belongs in the XY plane. All right. So when we're working in chapter 11, you might want to try to get your hands on some graphing paper, and I will try to attach some to our Canvas website here. We're going to call this the x-axis, this is the y-axis here. And we're going to learn how to plot a couple of points here, okay? Let's call this first point A here, which is going to be the point 2, 0. To plot points in the XY plane or ordered pairs in the XY plane, we always start at the intersection point between the X and the Y axis. This intersection point is called the origin of the XY plane. The origin. And the origin of the XY plane has the ordered pair address of 0, 0. That's called the origin. So we start at the origin, and my x coordinate of this ordered pair is +2. My y coordinate is 0. So if I start at the origin, I should be able to move 2 positive units along the x-axis, 1, 2, and then we will stay on the x-axis since my y coordinate is 0. So we move 2 positive units on the x-axis, 1, 2 from the origin, and we stay right here on the x-axis. So there's the location of point A. Any questions how we plotted point A at 2, 0? Let's plot point B, which is going to be -3, 5. So how do we plot the ordered pair or the point -3, 5? We start at the origin. And notice my x coordinate is -3. And my y coordinate is +5. So if I start at the origin, I got to move 3 units in the negative x direction, -1, -2, -3. And now I move up 5 units parallel to the positive y axis. So 1, 2, 3, 4, 5. And there's the point B that has the unique ordered pair address of -3, 5. Any questions how we're plotting points in the XY plane here? Point C, let's say this point here is going to be -6, -8. How would we plot point C? So we start at the origin. My x coordinate is -6. My y coordinate is -8. So I start at the origin. I move 6 units in the negative x direction, and then I move down 8 units parallel to my y axis. So starting at the origin, 6 to the left, 1, 2, 3, 4, 5, 6. There's -6. Now we go down 8 units, -1, -2, -3, -4, -5, -6, -7, -8. And there is the point C that has the unique ordered pair address of -6, -8. Notice point B lies in quadrant number 2. Remember, these are the quadrants, quadrant 1, quadrant 2, quadrant number 3, and quadrant number 4. Point B lies in the 3rd quadrant, point C lies in the point B lies in the 2nd quadrant, point C lies in the 3rd quadrant. Point A does not lie in a quadrant, it lies on the x-axis. Let's plot point D, which is going to be the point 7, -4. To plot point D, we start at the origin, and I move 7 positive units along the x-axis and then down 4 units parallel to the y-axis. So we start at the origin, move 7 to the right. 1, 2, 3, 4, 5, 6, 7, and we move down 4. -1, -2, -3, -4. And there is the point D, and that lies in the 4th quadrant. Any questions how I'm plotting points? Point E, this plot 0, -8. Where would we plot point E, 0, -8? We start at the origin, and how do I move? My X coordinate is 0, so we don't move right or left away from the origin. We stay on the Y-axis, and we move 8 units down on the Y-axis. So -1, -2, -3, -4, -5, -6, -7, -8. And there would be the point E there, 0, -8. Any questions, ladies and gentlemen, how we're plotting points in the XY plane? Now, when they use the word graph means the same thing as the word plot. So if it says graph the following ordered pairs, that means plot them in the XY plane. Same thing. Graph means plot. All right. Okay, ladies and gentlemen, let's try these problems here, 21 through 30 here. Can anybody give me the ordered pair address of the location of point number 21? Well, it'd be great if we could see it, first of all. There's a lot of distortion here in this picture. All right, whatever. I'll tell you what I'm going to do here is I'm just going to point to I'm going to put my pointer on a point, and you tell me what the X and Y coordinates of the point is. What's the X and Y coordinate of this point here? Looks like, I don't know, point 20 here. What would be the X coordinate of this point? Anybody? X coordinate.
The X coordinate will be 3.
+3. You project it right down to the X axis. And what's my Y coordinate?
+4.
Projected horizontally back to the Y axis. This point has a Y coordinate of
3.
Looks like 4. Also +3. So the ordered pair address of this point is 3, 3. Okay. All right. How about this point up here in the second quadrant? What would be its X coordinate right here where my pointer's pointing? The X coordinate would be projected right down to the X axis. It hits what? -4 for the tick mark, and the Y coordinate projected horizontally back to the Y axis is +4. So it looks like the ordered pair address associated with this point would be -4, 4. All right. What would be this point right here that I'm pointing at? Down, right down here. This point right down there. What would be the X coordinate of this point?
-5 and -5. No, 0 and -5.
Yeah, the X coordinate is 0 because if you this point is sitting right on the Y axis. So if you project it straight up to the X axis, you hit the 0th tick mark on the X axis. So the X coordinate is 0. The Y coordinate is -5. So this point would be 0, -5. All right. How about this point right here? What would be its X coordinate? This point right here. What's its X coordinate?
The X coordinate would be 5.
All right. +5, and the Y coordinate would be?
-2.
-2. So the ordered pair address of this point would be open parenthesis 5, -2, closed parenthesis. Correct?
Correct.
All right. What would be the ordered pair address of this point right here? This one here that lies on the X axis. What's the X coordinate of this point?
Wouldn't it be? It'll be 0 and -3.
But the X coordinate is what? The X coordinate's -3.
-3.
And then the Y coordinate is what? 0, correct?
Yes.
So this point here would be -3, 0. So you got to make sure you get the ordered pairs correct. It's always the X coordinate first and then the Y coordinate. All right. That's always the required order for an ordered pair. Okay. So basically what this is doing, ladies and gentlemen, is it's giving you practice in plotting points in the XY plane. And we're going to do more work in the XY plane. So there's not really too much going on with section 11.1. They're just basically warming you up to the XY coordinate system, and they're having you just plot points in the XY plane. Okay. So let's begin to move into section 11.2 now. which is entitled, we're going to start learning how to graph linear equations in the XY plane in 11.2. All right. All right, so what does that mean? All right, so what we're going to do is we're going to start working with linear equations in two variables, x and y. Okay. So in general, these equations are going to look like this. This is called a linear equation in x and y. It's called linear because x and y are raised to the first power. And solutions to such an equation always have to be ordered pairs. And of course, ordered pairs look like this. All right. So what does it mean for an ordered pair to be a solution to such an equation? Well, it means that the ordered pair has to satisfy the equation. So what I'm going to do is I'm going to just pull this out of thin air and ask ourselves a question. Is the ordered pair 2, 3 a solution to the equation So we're going to ask ourselves, is the ordered pair 2, 3 a solution to this linear equation in x and y? Well, if it's a solution, it has to satisfy the equation. So what am I going to replace the x variable with? I'm going to replace the x variable with the x coordinate of this ordered pair. So 2 drops in place of x. The y variable is replaced with the y coordinate of this ordered pair, which is to say we replace y with 3. So let's see if 2, 3 satisfies this equation. So is it true that 3 times 2 plus 4 times 3, is that true that that's equal to 5? Well, 3 times 2 is 6, 4 times 5 is 12. Is 6 plus 12 equal to 5? Is 18 equal to 5? And the answer is what? No. And so, ladies and gentlemen, 2, 3 is not a solution to the linear equation 3x plus 4y equals 5. Not a solution. It's not a solution. It doesn't work. All right. Now here comes a real tough question. Can anybody think of a solution to that equation? Anybody think of an ordered pair that would be a solution to that equation? Well, that's far from obvious. Do you agree? All right, all we know is 2, 3 is not a solution. That's all we know so far. Okay. So let's see, let's try another one here. Is the point 3, -1 a solution to the linear equation 3x plus 4y equals 5? Well, we got to test it out. So I'm going to replace the x variable with the x coordinate and the y variable with the y coordinate. So in for x goes 3. So we got 3 times 3 plus 4 times y is replaced with -1. Question, is that equal to 5? 3 times 3 is 9. 4 times -1 is -4. Is 9 minus 4 equal to 5? Does it work? And you can see that it does check out. So the answer is yes. 3, negative 1 is a solution of the linear equation 3x plus 4y equals 5. It's a solution. It works. Any questions how we're verifying whether an ordered pair is a solution to a linear equation? Okay. Go back to our textbook. We're working in section 11.2 right now. Go down to our problem set down here. Problems begin right down here. All right. So, ladies and gentlemen, in problems 1, 2, 3 onward here, it says, for each equation, complete the given ordered pairs. In other words, they're going to give you either the x or the y coordinate of the partially completed ordered pair, and they want you to find the missing coordinate so that it is a solution to the linear equation that is presented. So if we look at problem number, I'm going to do number 2. Number 2 here, they give us a linear equation, which is 3x minus y is equal to 5. And they want us to complete these ordered pairs here so that they are solutions to this linear equation. Well, the first ordered pair, they give us the x coordinate is 0. We have to find the y coordinate. So how do we do that? Well, they give us the x coordinate is 0. We got to find the y coordinate. So we know x is 0. So what we're going to do is we're going to substitute in 0 in for the x variable into our equation, because they tell us that x is equal to 0. So therefore, our linear equation is going to be 3 times 0 minus y equals 5, which is going to be 0 minus 5 is equal, 0 minus y is equal to 5, which is negative y is equal to 5. And now we have to solve this equation for y, and we do so by dividing both sides by a negative 1, and this implies that y is equal to negative 5. So the missing y coordinate of this ordered pair, ladies and gentlemen, has to be negative 5. We say now that 0, negative 5 is a solution to this linear equation. Questions how we did that? Let's do another one now. The next ordered pair they give us has the next coordinate of being 1, and they want you to find the missing y coordinate such that that ordered pair would be a solution to our linear equation. So now they're giving us the x coordinate as 1, and they want us to find the y coordinate. So now we know x is equal to 1, so we're going to substitute 1 in for the x variable into our equation, which means we'll have 3 times 1 minus y equals 5. And now we just solve for y. This is going to be 3 minus y equals 5. To solve for y, we subtract 3 from both sides. 3's drop out on the left, leaving you with negative y. And 5 minus 3 on the right side is 2. Divide both sides by a negative 1, and we walk out of this with y having a value of negative 2. So if x is equal to positive 1, y has got to be equal to negative 2 in order for this ordered pair to be a solution to this linear equation. Any questions how we completed that ordered pair there? All right, the last ordered pair, they give us the y coordinate is 5, and they want us to find the missing x coordinate such that this ordered pair would be a solution to our linear equation. So now they give us the y coordinate is 5, and they want us to find the missing x coordinate. So to do so, we're going to take 5, substitute it in for the y variable into the equation. And now we're going to have to solve for the x coordinate here. To do that, we add 5 to both sides of their equation. We will have 3x equals 10. Divide both sides by 3. And this implies that x is going to be equal to 10/3, which for plotting purposes, you might want to turn 10/3 into a mixed number, which would be 3 goes into 10, what, 3 times with 1/3 left over, correct? So 3 1/3 would have to be the missing x coordinate of this ordered pair if it's to be a solution to our linear equation up here. Any questions how we're completing an ordered pair for a linear equation given one of its coordinates? All right, so we'll let that go there. All right, that's how you're going to do these problems here, any one of these problems. Now, we have an interesting situation in number 9 and number 10 here. Notice the linear equation in number 9 says x is equal to -5, and you don't see the y variable anywhere. You're probably wondering where in the heck's y? Well, technically y is in the equation. It's just that 0 is being multiplied by y. And that's why y does not contribute to the value of this equation, only x does. Namely, x is always equal to -5. So for this problem number 9 here, to complete all these ordered pairs means to find the x coordinates of these ordered pairs such that they would be solutions to this equation. Well, this is a very easy problem, ladies and gentlemen, because the x coordinates of every one of these ordered pairs has to be -5, because x is always equal to -5. And so this is -5, -5, -5. All of these ordered pairs now would be solutions to this equation. They're all solutions. All right. In a similar fashion, problem number 10 gives us a linear equation with only the variable y present and not the variable x. And this equation, according to this equation, y is always equal to +2. So to complete these ordered pairs here, we need to find the missing y coordinates. Well, what do you think the y coordinates are going to be for every one of these ordered pairs? The y coordinate should be 2, because y is always equal to 2 according to this equation. So now all of these ordered pairs would be solutions to this linear equation. Those are easy cases, correct? All right. Now, ladies and gentlemen, they're going to give us a linear equation, and they want us to complete the table for this linear equation. And this table really is going to have us find ordered pair solutions to the equation as we complete the table here. All right, I'll do one like number 18, problem 18. They give us a linear equation, which is 3x minus y is equal to 9. And they want us to complete this partially completed table here. So in some cases, they give us the x coordinate. In other cases, they give us the y coordinate, and we got to find the missing coordinates here. So to do problem number 18, this is the problem. This is the linear equation we're working with. All right, so we have to find the x coordinate if the y coordinate is equal to 0, so that this ordered pair is a solution to this linear equation. To do that, I will replace the y variable with 0. So my equation, after doing that, becomes 3x minus 0 equals 9. And now I can solve for x. To solve for x, we divide both sides by 3, and this implies that x is equal to 3. So the missing x coordinate of this ordered pair is 3. So 3, 0 would be a solution to this linear equation. When y is equal to -9, what would be the x coordinate? Well, to find out, replace y with -9. And let's solve for x here. So subtracting a -9 is the same thing as adding +9. Now to solve for x, we minus off 9 from both sides. We'll have 3x equals 0. Divide both sides by 3, and 0 divided by 3 is 0. So When the y coordinate is -9, the x coordinate has to be 0 if this ordered pair is to be a solution to that equation. When x now is equal to 5, we have to find the missing y coordinate if it's to be a solution to this linear equation. So now we set x equal to 5, substitute 5 into our linear equation for x, in which case we'll have 3 times 5 minus y equals 9. And now we just have to solve for y. This is going to be 15 minus y is equal to 9. Subtract 15 from both sides. Negative y is equal to -6. Divide or multiply both sides of this equation by -1. And we get y is equal to +6. And so therefore, when the x coordinate is 5, the y coordinate has to be +6 if this ordered pair is to be a solution to our linear equation. Finally, when x is equal to -4, what must y be? To find out, take -4, substitute it in for the x variable. In which case we got -12 minus y is equal to 9. To solve for y, we add 12 to both sides. We get -y is equal to 21. Divide or multiply both sides by a -1. And y walks out of this with a value of -21. And therefore, there's another ordered pair solution to our linear equation, -4, -21. Any questions, ladies and gentlemen, how we completed that table for that linear equation? And hence, we are looking at 1, 2, 3, 4 ordered pair solutions to this linear equation. Which leads us to believe how many ordered pairs are solutions to this linear equation? How many ordered pair solutions does a linear equation in x and y have? That's a good question, of which we're going to be answering in the near future. Okay. All right. Okay, so so, ladies and gentlemen, what are we going to do with these linear equations besides, just verifying whether ordered pairs are solutions? Well, where we're going with this is we're going to learn how to graph a linear equation. To graph a linear equation, and a linear equation in general looks like this, means to plot all ordered pair solutions in the XY plane. Well, okay. So that brings us to the question again. How many ordered pair solutions do these linear equations have? How many? Well, I'll let you in on a little secret, ladies and gentlemen. Linear equations in X and Y have, you ready for this? They have an infinite number of ordered pair solutions. Infinite number. Well, now, how are we going to plot an infinite number of ordered pairs in the XY plane? We would be here till the end of time or death, whatever grabs us first. Well, ladies and gentlemen, in the word linear, you see the word what embedded in the word linear? The word line. So the graph of a linear equation. The graph of a linear equation is always a line in the XY plane. Hence, it is enough to plot at least two ordered pair solutions. To graph a linear equation. Because think about it, ladies and gentlemen, bare minimum, how many points do you have to plot in the XY plane to determine a unique line? Bare minimum, how many points must you plot in the XY plane to determine a unique line? Well, to determine a unique line in the plane, we have to plot bare minimum 2 points, at least 2 points. 1 point's not good enough, because if you only plot 1 point, there's an infinite number of lines that can go through 1 point. Infinite number. Infinite number of lines. So to determine a unique line in the plane, we have to plot bare minimum at least 2 different ordered pair solutions or points. That will determine a unique line in the plane. So that's how we're going to graph a linear equation. All we have to do is come up with at least 2 ordered pair solutions, of which we'll plot in the plane, and then we'll put a line through them, and we'll have the graph of our linear equation. It's that simple. All right. So let's just dive right in and try this out here. Let's try to graph y equal to 2x. Let's try to graph this in the XY plane. In fact, I'll do it right here. All right. So we're going to try to graph the linear equation that is presented to us in the form of y equal to 2x. A popular way to graph a linear equation is to use what's called the table method. So we'll make a table here. The first column of which is going to be called the x coordinate column. The second column of which is going to be called the y coordinate column. And then what we do is we start choosing some convenient values of x, of which we'll plug into the equation for x and then solve for y. Now, since we can choose anything for x, don't choose nasty values. In other words, don't choose like 1,000 for x, because there's no way you're going to be able to plot 1,000 in your XY plane. You'd have to go too far to the right on the x-axis to plot the point. So keep the values of x close to 0. How about -2, -1, 0, 1, 2? Let's choose these values for x. Now, if x is equal to -2, what must y be equal to if it's to be an ordered pair solution of this linear equation? Well, y is going to have to be equal to 2 times -2 or -4. And so, ladies and gentlemen, we have an ordered pair solution, -2, -4 for our linear equation. If x is equal to -1, what must y be? To find out, take -1, substitute it in for the x variable into the equation, and solve for y. Hence, y will be -2. If x is equal to 0, what would y be? Take 0, substitute it in for x, solve for y. Y would have to be 2 times 0 or 0. If x is equal to 1, what's y? Replace x with 1 and find out. Y would be equal to 2 times 1 or 2. If x is 2, what would y be? Replace x with 2. into the equation to solve for y. Y would be equal to 2 times 2 or 4. Any questions how we generated these ordered pair solutions for this linear equation by using this table? All right, now we have ordered pairs that need to be plotted so that we can see their ordered pairs. I'm going to attach another column to this table called my ordered pair column. So we got to plot -2, -4. We got to plot -1, -2. We got to plot 0, 0. We got to plot the point 1, 2, and we got to plot the point 2, 4. So let's take these points and plot them in the XY plane over here. This will be my x-axis. There's my y-axis. Please put arrows on the end of your axes. All right, now we're going to plot some points. We're assuming that on both the x and y-axis, the tick marks are spaced 1 unit apart. So to plot -2, -4, we start at the origin. I move 2 to the left on the x-axis, and then I move down 4 units. So -1, -2, now down 4, -1, -2, -3, -4. There's the point, -2, -4. You can label the point if you want to with its ordered pair address. It does clutter up your diagram, but feel free if you want to do that. To plot this other ordered pair solution of our linear equation, -1, -2, we start at the origin. I move 1 to the left on the x-axis, and then I move down 2 units parallel to my y-axis. Start at the origin, 1 to the left, now down 2, -1, -2. There's -1, -2 right there. Plotting the next ordered pair solution, which is 0, 0. Well, 0, 0, ladies and gentlemen, is called the origin of the XY plane. 0, 0 is right there. That's 0, 0. Plotting 1, 2, we start at the origin and I move 1 unit in the positive x direction, then up 2 units parallel to my positive y direction. So 1, 2, start at the origin, 1 to the right, now up 2, 1, 2, there's 1, 2. Plotting the point 2, 4, we start at the origin, move 2 to the right on the x-axis, and up +4 units. 1, 2, now up 4, 1, 2, 3, 4, there's 2, 4. I got a question for you. Does it look like those points lie on a line, ladies and gentlemen? Does it look like those points, those solutions to that linear equation lie on a line? Yes or no? What do you think, Lydia? Does it look like those points are collinear points? Do they lie on a line?
Yes.
All right, so what we're going to do is we're going to take a ruler now. We're going to put a nice straight line right through those points. Take a ruler, put a line through these points. And ladies and gentlemen, what you're looking at here is the graph of that linear equation y equals 2x. This line is the graph of this linear equation. And any point that sits on this line would be a solution to this linear equation. Got a question. How many points are on this line? How many points are on this line? These arrows mean this line goes forever in respective directions. How many points are on this line? There's an infinite number of points on this line. Infinite number. And that's why there's an infinite number of solutions to this equation, correct?
Mm-hmm.
So I have a question for you. Would this point here be a solution to my linear equation? Is that a solution?
No,
How do you know that?
it's not on the line.
Doesn't lie on the graph of the linear equation. It's not a solution. Is this point here, this nasty point of which we cannot even read the x and y coordinates off of, nonetheless, is it a solution to my linear equation?
Yeah.
Yes, because it lies on the graph. This linear equation doesn't always have nice ordered pair solutions, ladies and gentlemen. Sometimes the x and or y coordinates are messy decimals or fractions, but nonetheless, there's an infinite number of points, some with nice x and y coordinates, some with very, very messy x and y coordinates. But nonetheless, there's an infinite number of points that lie on this line. Infinite number of solutions to that linear equation. Any questions how I graph that linear equation using this table method? Now, your authors here says, find 3 solutions to each of the following equations and then craft the solution set or craft a linear equation. For the problem I did, ladies and gentlemen, I went further. Not only did I not find bare minimum 2 ordered pair solutions, I found 5 of them. You agree? 2 is good enough, but 3 ordered pairs are better. I'll show you why. Sometimes when you just plot 2 ordered pairs, you can get into trouble if you're sloppy and putting a line through them. For instance, if I plotted 2 ordered pair solutions to a linear equation, I could put my line through these points that look like this. Or ladies and gentlemen, I could put my line through these points that looks like this. Do you agree I did a very sloppy job in putting a line through those points? And so it looks like these lines have radically different slants, or we say slopes to them. Do you agree? To correct for this possible ambiguity, it's better to plot 3 points. That way you can't miss in putting a line through all 3 points. Or word of advice, if you're only going to plot 2 ordered pair solutions, just make sure the line goes through the center of the points, the center of each point. And that should be a pretty accurate graph, okay? Just be careful how you put a line through 2 points if you're only going to use 2. All right, let's try another one here. Let's try to graph this linear equation in number 60 here. Negative 3x plus y equals 1. The instructions will say graph. So all it's got to say is graph. So how are we going to graph this linear equation? Well, we're going to have to generate some ordered pair solutions to this linear equation. To help us, we can make a table. First column is the X column, second column is the Y column. And I like to have the third column be my ordered pair column. And ladies and gentlemen, we can choose any values for X or Y for that matter, and then solve for the other variable. Normally we choose values for X, plug them in and solve for Y. Can you give me some nice X values to plug in this equation? Nice X values. Nice X values, ladies and gentlemen. Nice X values. Give me a couple nice X values. Please don't give me like nasty ones like 10,000. Don't let X be 10,000. You're never going to be able to plot that point. Give me something nice. Some nice X values. Go ahead, anybody. Nice X values. Hey, Sophia, are you with us here today?
Yes.
Can you give me a couple of nice X values so I can generate some ordered pair solutions to this linear equation?
3, 4, 5.
All right, 3, 4, 5. Those should be pretty easy to plot. You know what also is a nice value to choose? 0. 0 is always the nicest value to choose because that means one of your variable or terms is going to drop out, which vastly simplifies the situation. All right, so if X is equal to 3, we got to solve for Y. So I put 3 in for the X variable into the equation. And now I got to solve this equation for Y. So we have negative 9 plus Y equals 1. To solve for Y, I add 9 to both sides. In which case I get Y is equal to 10. So I have one ordered pair solution, 3, 10. Good. Now we'll let X be 4. If X is equal to 4, we got to find Y. Take 4, substitute in for the X variable into the equation, and then solve for Y. This is going to give us negative 12 plus Y equals 1. We're going to add 12 to both sides to solve for Y. Y is equal to 13. We have another ordered pair solution called 413. To find another ordered pair solution, let's let X be 5. If X is equal to 5, what's Y? Take 5, substitute it in for the X variable in the equation, and then solve for Y. This is going to be, this is going to be negative 15 plus Y equals 1. Add 15 to both sides of your equation. And this implies that Y is going to be equal to 16. There's another ordered pair solution to this equation. Finally, let x be equal to 0. Take 0, substitute in for the x variable into the equation, and then solve for y. This is going to be 0 plus y equals 1, so y equals 1. Ladies and gentlemen, we found another ordered pair solution. I think we have more than enough ordered pair solutions to accurately graph this linear equation in x and y. So let's take these points to the xy plane and plot them. So ladies and gentlemen, I'm going to plot these points in the xy plane here. There's my y-axis. Here's my x-axis. How do I plot 310? I start at the origin, I move 3 to the right on the x-axis, then I move up 10. Here we go. 1, 2, 3, now up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way up there. That's 310. 413, I'm not going to be able to plot. I won't be able to go as high as 13. 516 won't be able to plot. 01 I can plot. Start at the origin, stay on the y-axis, and go up 1. Right there. There's 01. I think we have enough points to graph this linear equation. Ladies and gentlemen, we plotted 2 points. That should be good enough. Take a ruler, make sure you put the line right through dead center of those points. And you are looking at the graph of that linear equation. Y, or rather negative 3x plus y equals 1. Everybody understand how we graph this linear equation using our table method there? That's the graph, that line. Make sure you always put arrows on the end of the line. That's very important because your line has to go in respective directions forever. Just making sense, ladies and gentlemen, how we're graphing linear equations using the table method? All right, well, you want to try one now? Classwork number 1. Okay, classwork number 1. I want you guys to try problem number 62 for classwork number 1. Let's see if we can graph that linear equation in number 62. So classwork number 1, problem number 62. I want you to, using the table method, I want you to graph 3x minus 4y is equal to 8. There you go, ladies. I'm going to see if you can graph number 62 there. Okay, we'll call that classwork number 1. Today is the 17th day of February. St. Patrick's Day is exactly 1 month from today. Isn't that something? St. Patrick's Day. All right, go ahead. Graph number 62. Now, the X values you choose to plug into that equation to generate ordered pair solutions does not matter. Yours might differ than mine. That's not important. What is important is that our graphs better look identical when we get done graphing them. All right, so I chose 0, 2, and 4 for my X values. You may have chose other values. The bottom line is, so when we plot these points and connect them with a straight line, we better have the same graph. So I'm going to plot these points now on my XY plane. So to do that, to plot the ordered pair solution 0, -2 that I got, I start at the origin and I move down to -1, -2. There's 0, -2. Plotting 2, -1/2. We're going to go over 2 and then down 1/2. 2 to the right, +1, +2, and then down 1/2. Down -1/2. It's halfway in between 0 and -1. Now we'll plot 4, 1, start at the origin, go 4 to the right, 1, 2, 3, 4, and then up 1. There's 4, 1. Take a ruler, put a line through these points, and we have the graph of that linear equation. The bottom line is, does your graph look the same as my graph? The lines have to be in the identical position in the XY plane. Does yours look like that, ladies and gentlemen? Because if it does, it's correct. That would be the graph of that linear equation. Any questions how we graph that linear equation? It's called the table method for graphing a linear equation. All right. Now, let's try to graph one that looks like this. This gives you a slightly different look. What if I want to graph a linear equation y x = 5? Well, you're going to use the table method to generate some ordered pair solutions for this linear equation. This equation is saying x is always equal to 5 regardless of what y is. So ladies and gentlemen, it doesn't matter what y is, x is always 5. So if y is equal to 1, x is 5. If y is equal to 0, x is 5. If y is equal to -4, x is 5. If y is 2, x is 5. X is always 5, regardless of what y is. Y could be anything, but x is always 5. So we got some ordered pairs here, ordered pair solutions to this equation. And now what I will do is I will plot these and graph that linear equation. So to do so, we take our graphing paper here. Got our x and y axis here. This is going to be my x-axis and this will be my y-axis. All right, so to plot these points here, plotting 5, 1, start at the origin, go 5 to the right, 1, 2, 3, 4, 5, and then up 1. There's 5, 1. Plotting 5, 0, start at the origin, go 5 to the right, 1, 2, 3, 4, 5, and then stay right on the x-axis. There's 5, 0. 5, -4, start at the origin, go 5 to the right, 1, 2, 3, 4, 5, then down 4, -1, -2, -3, -4. Start at the origin, plot 5, 2, start at the origin, go 5 to the right, 1, 2, 3, 4, 5, now up 2, 1, 2, there's 5, 2. What do you notice about these points? They all lie on a line. What kind of line is this? It's a vertical line. And there you go, ladies and gentlemen, that'd be the graph of x = 5. It's that vertical line in the XY plane. It goes through the x-axis at 5. Any point on this line would always have a y coordinate, an x coordinate stuck at a value of 5. Y coordinate could be anything, but the x coordinate's always 5. Questions how I graph that vertical line? I'll let you in on a little secret. It's a well-known fact that when your linear equation looks like this, x = some number, the graph of this type of linear equation is always going to be a vertical line. And this vertical line will go through the x-axis at C, whatever this number C is. Okay, it's always a vertical line. All right, let's try to graph this linear equation here. Let's graph y = 4. To graph this linear equation, you know, you can make your little table here. Now we can see that no matter what X is going to be, Y is always going to be what? 4. So Y is always 4. So if X is chosen to be 5, Y is 4. If X is chosen to be 1, Y is 4. X is 0, Y is 4. If X is -1, Y is 4. If X is -4, Y is 4. Y is always 4. So we have a whole bunch of ordered pair solutions now of which we can take to the XY plane and plot. All right, so now what I can do is I can plot these in the XY plane. And I'm curious to see what kind of graph Y equals 4 is going to be. Well, plotting 5, 4, start at the origin, go 5 to the right. 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. There's 5, 4. Plotting 1, 4, start at the origin, go 1 to the right, now up 4. 1, 2, 3, 4. There's 1, 4. Plotting 0, 4, we start at the origin and I go just up 4. I don't go right or left because my X coordinate is 0. 1, 2, 3, 4. There's 0, 4. Plotting -1, 4, start at the origin, go 1 to the left, and then up 4. 1, 2, 3, 4. There's -1, 4. Plotting -4, 4, starting at the origin, we go 4 to the left, and then up 4. -1, -2, -3, -4. Now up 4. 1, 2, 3, 4. Take a ruler, put a line through these points, and what kind of a line do you think this graph is going to be? It's going to be a horizontal line. So the graph of Y equals 4 is that horizontal line that goes through the Y-axis at 4. Makes sense because any point on this line must always have a Y coordinate of 4. The X coordinate could be anything, but the Y coordinate is always 4. Let you know a little secret, ladies and gentlemen. It's a well-known fact that when your linear equation has just a Y variable equal to some number, the graph is always going to be a horizontal line. And this is going to go through the Y-axis at C, whatever that number C is, okay? All right. So any questions how we graph a linear equation from section 11.2? All right, 11.3 is the last section we'll cover today. It's entitled Graphing Linear Equations using what are called intercepts, okay, using intercepts. What's that all about? Well, we're going to find out. So 11.3. All right. What are these things called X and Y intercepts? Well, suppose I have a linear equation and I graph it in the XY plane, and suppose that my line graph looks something like this. Ladies and gentlemen, where this line intersects the x-axis, that point of intersection between the graph of the linear equation and the x-axis is called the x-intercept. The point of intersection between the graph and the y-axis is called the y-intercept. So that's what an x and y intercept is. Now, an x-intercept is always a point that lies on the x-axis, being the point of intersection between that axis and the graph. Because of that, because that x-intercept is a point on the x-axis, its y-coordinate always has to be equal to 0. Think about it. Because if a y-coordinate of a point's not 0, then the point will not even be on the x-axis. It's either going to be above the x-axis or below. To be a y-intercept, a point has to lie on the y-axis and marks the point of intersection between that axis and the graph. Since a y-intercept is a point that lies on the y-axis, its x-coordinate must always be equal to 0. So that's how we're going to find x and y intercepts of a linear equation. So to find an x-intercept of a linear equation, we always set what equal to 0. We always set the y variable equal to 0. To find a y-intercept of a linear equation, we always set the x variable equal to 0. There you go, ladies and gentlemen. So that's how you're going to find an x and y intercept by always setting the other variable equal to 0. Easy way to remember it is to find the x-intercept, you set the other variable y equal to 0. To find the y-intercept, you set the other variable x equal to 0. So this provides an alternative way for graphing a linear equation if we can find its x and y intercepts. That's good enough. That provides us with 2 unique points, and we can just put a line through the points to get the graph. So let's see if we can do such a thing. Okay. All right, so we're going to try this out now. Hold on a second here. I'm going to call this the x-axis, this the y-axis. This is all turned around. Okay. Well, here we go. I'm going to try one out here. So the instructions are going to say graph the equation by finding the x and y intercepts. And here's the equation we're going to play around with. 2x plus 5y equals 10. Okay. So we're going to try to graph this equation by finding the x and y intercepts. First of all, we'll find the x-intercept. The x-intercept is always found by letting y be equal to 0. So we're going to let y be 0, take 0, substitute it in for the equation into the y variable. And now we're going to solve this equation for x. So this is going to be 2x plus 5 times 0 is 0 is equal to 10. 2x equals 10, divide both sides by 2, and x walks out of this with a value of 5. So my x-intercept is 5, 0. That's my x-intercept. It's through this point that the graph of this linear equation will cross the x-axis at. Any questions how I computed the x-intercept for this linear equation? All right, to find the y-intercept is equally easy. To find the y-intercept, we always set x equal to 0. Take 0, substitute it in for the x variable into the equation and solve for y. So this is going to be 0. Hence, we have 5y equals 10. Now we're going to have to divide both sides of our equation by 5. And this implies that y is equal to what? 2. So my y-intercept is the ordered pair of 0, 2. Any questions how I found the x and y intercepts for this linear equation? Notice to do so, you always set the other variable equal to 0. Now let's plot our x-intercept, which is 5, 0. To plot it, we start at the origin. And I move 5 to the right on the x-axis and stay on the x-axis, my y-coordinate 0. So 1, 2, 3, 4, 5. There's my x-intercept, 0, 5. 5, 0, excuse me. Now my y-intercept is 0, 2. To plot 0, 2, we start at the origin. We stay on the y-axis. Since my x-coordinate 0, we just move up 2. So 0, 2, 1, 2, 0, 2 is going to be right here on the y-axis. There's my y-intercept. There's my x-intercept. There's my y-intercept. Take a ruler, put a line through the points, ladies and gentlemen, and we have the graph of that linear equation. It's that simple. There's your answer. That is the graph of the linear equation 2x plus 5y equals 10. And we graphed it by finding the x and y intercepts of that linear equation. Any questions how we graph that equation by finding x and y intercepts? All right. Maybe we could try another one here. All right, let's see if I can do number 10. See if I can graph that linear equation by finding the x and y intercepts. So graph by finding x and y intercepts. So my equation is negative x plus 2y is equal to 2. All right. So ladies and gentlemen, we're going to try to graph this linear equation by finding the x and y intercepts. First, let's find the x-intercept. Doesn't matter which intercept you find first, by the way. The x-intercept is always found by letting y be equal to 0. Take 0, substitute in for the y variable into the equation. The equation collapses down to negative x plus 2 times 0 equals 2. This is going to be negative x plus 0 is equal to 2. So negative x equals 2. Divide or multiply both sides of this equation by a negative 1. And we get x is equal to negative 2. So your x-intercept is going to be the ordered pair negative 2, 0. That's your x-intercept. Now to find the y-intercept of this linear equation, we're going to set x equal to 0 always. Take 0, substitute it in for your x variable into the equation, and then we'll solve the equation for y. This is 0. This is going to be 2y equals 2. Solving for y, we divide both sides by 2, and y walks out of this with a value of 1. So my y-intercept is 0, 1. Now that I have my x and y intercepts for this linear equation, I should be able to plot these two intercepts and put a line through them to graph this linear equation. That's all there is to it. So let's take a piece of graphing paper here and see if we can graph that linear equation. All right, plotting my x-intercept starting at the origin. I move 2 to the left on the x-axis and stay on the x-axis since my y-coordinate is 0. So -2, 0 is going to be 2 to the left from the origin. -1, -2. There's -2, 0 right there. So that's -2, 0. Plotting the y-intercept, which is 0, 1. We start at the origin. I do not move right or left on the x-axis. I just move up 1 unit on the y-axis. There's 0, 1 right there. Take a ruler, put a line through the points, the center of those points, and you have the graph of that linear equation. And there we go, ladies and gentlemen. That would be the graph of -x plus 2y equals 2. So we're graphing linear equations by finding the x and y intercepts of the equation. Any questions? All right, let's try this one here. This one's going to be a little interesting. Let's try to graph the equation y equals 3x by finding the x and y intercepts. Well, to find the x-intercept, we're going to set y equal to 0. Take 0, replace the y variable with 0. We have this equation here that has to be solved for x. To solve for x, we divide both sides by 3. And we get 0 is equal to x. So my y-intercept is going to, x-intercept rather, is going to be the ordered pair 0, 0. Well, ladies and gentlemen, 0, 0 happens to be the what? The origin. Do you agree? Looks like the x-intercept's the origin. To find the y-intercept for this linear equation, we're going to let x be equal to 0. Take 0, substitute it in for the x variable into this equation, and we get y is equal to 3 times 0, which means y is equal to 0. So 0, 0, the origin also happens to be the y-intercept. Well, since the x and y-intercept are the same point, namely the origin, that's not going to be good enough in order to graph this linear equation. We're going to have to generate literally at least one more ordered pair solution to this equation if we're going to be successful in graphing it. So ladies and gentlemen, we have to take it upon ourselves to find another ordered pair solution to this linear equation. To do so, choose some other nice value for x. I'm going to let x be equal to 4. Wrong, no good. I'm going to let x be equal to 2. If x is equal to 2, then y is going to be equal to 3 times 2, or 6. Now we have another 0.26 that we can plot along with our x and y intercept. That should be enough to graph that linear equation. Well, let's take a piece of graphing paper and see if we can graph it. So let's plot the x and y intercepts first. Both of those are the origin right here. And we're going to plot this other ordered pair solution we discovered, which is 2, 6. To plot 2, 6, we start at the origin, move 2 to the right, 1, 2, now up 6. 1, 2, 3, 4, 5, 6. There's 2, 6. So I'm going to take a ruler and I'm going to put a line through these points here. And ladies and gentlemen, you are looking at the graph of that linear equation, y equals 3x. That is the graph of that linear equation. It's that line. Any questions how we did that problem? All righty. Okay, so I'm going to give you classwork number 2 here. I want you to try to graph Oh, let's see. Let's see if you can graph number 16, that linear equation of number 16, by finding the X and Y intercepts. So let's see if you can graph negative 5X plus 4Y equals 20 by finding the X and Y intercepts. All righty, so we'll call that classwork number 2, Lizzo. Go ahead and see if you can graph that linear equation by finding the X and Y intercepts. All right, so let's try to find the x and y intercept for this linear equation. To find the x-intercept, we let y be equal to 0. Take 0, substitute it in for the equation, and then solve for x. This is gone. Divide both sides by -5, and it looks like the x-intercept is going to be -4. To find the y-intercept, we let x be equal to 0. Take 0, substitute in for the x variable into the equation. This is gone. You're left with 4y is equal to 20. Divide both sides by 4. Y is equal to 5. Y-intercept is 0, 5. So now we know the x and y intercepts. That should be enough to graph the linear equation. To do so, all we're going to do is plot the x-intercept, which is -4, 0. Start at the origin, go 4 to the left on the x-axis, -1, -2, -3, -4. There's -4, 0. That's your x-intercept. Plotting the y-intercept, which is 0, 5. Start at the origin, go up 5. 1, 2, 3, 4, 5. There's 0, 5. Put a line through these points and you will have the graph of your linear equation. Did anybody get that graph? So that is the graph of -5x plus 4y equals 20. So we graph that linear equation by finding the x and the y intercepts. Any questions how we graph that linear equation, finding x and y intercept? And so that essentially is what the section's about. Now, sometimes you might have fractions in your equation, but you know, essentially things work out the same way. For instance, number 24 here, to graph number 24, you want to find the x and y intercepts. Nothing changes. The only difference is we have a fraction present, but other than that, everything else is the same. So to graph this linear equation, y equals 1/2 x minus 3, we want to find the x and y intercept. To find the x-intercept, we'll let y be 0. Replace the y variable with 0, and now we have this equation we have to solve for x. To solve for x, we're going to add 3 to both sides of our equation. And then we multiply both sides by 2. And we get 6 is equal to x. So my x-intercept is 6, 0. Now to find the y-intercept of this linear equation, we're going to let x be equal to 0. Take 0, substitute it in for the x variable, and then solve for y. This is gone, and we're left with y is equal to -3. Your y-intercept is 0, -3. So that should be enough then to graph that linear equation there. So let's see if we can graph that. So plotting the x-intercept of 6, 0. We start at the origin. We move 6 to the right on the x-axis. 1, 2, 3, 4, 5, 6. There's 6, 0. X-intercept. And then the y-intercept is 0, -3. Start at the origin, go down 3 on the y-axis. -1, -2, -3. There's 0, -3. Take a ruler, put a line through the points, and we're done. We have the graph of that linear equation. And that would be it. That would be the graph of y equals 1/2 x minus 3. So any questions how we're graphing linear equations, either by using the table method, finding, you know, ordered pair solutions by choosing convenient values for x, or by graphing a linear equation by computing its x and y intercepts. All right, if not, that basically in a nutshell, ladies and gentlemen, is what's going on in 11.1, 11.2, and 11.3. I will be making available the chapter 5 and 6 quiz. I'm going to roll it into one quiz and I'll send it out to you. All we got left in this course is just 3 more meetings, February 22nd, February 24th, and March 1st, and that's it. On Tuesday of next week, I will go over 11.4 through 11.6. 1 week from today, 12.1 through 12.3. And then 1 week from next Tuesday, March 1st, 12.4, 12.5, and 12.7 will wrap up Math 072. And I will be sending out a final exam, which will cover chapters 9 through 12. Okay. All right. Any questions, Liz-Owen? Any questions?
Yeah. I know we just recently turned in our midterm. Do you know when we'll be able to see that grade?
Yeah, I'm gonna get around to grading that. I also have to get your, I will be getting that graded, and I'll post that probably within the next day or so. Okay.
Okay, thank you.
All righty. Any other questions? All right. Well, have a good weekend, Liz. I'll see you next week.